All right, so what is this, map 21, we're looking at summer 2023. All my gluttons for punishment are here present for a 4.5 hour lecture. Y'all a bunch of psychopaths. We are doing chapter 6 today. We're doing chapter 6.1 and 6.2. Chapter 6 is on discrete probability distributions. Now, if you remember back to chapter 1, we said numerical data could be discrete or continuous. Continuous data is chapter 7. Chapter 6 is discrete, where we want like whole numbers, shit like that. So 6.1 is on discrete random variables. And before I dive into this, I am just going to give you the shit you need to know right away. So if you're watching this later on, this is the beginning of the video. For 6.1, you need to know that expected value, which we call E parentheses X, is the summation of X times P of X. And you'll want to know that in StatCrunch, we're going to do this with stats, calculators, custom. So we know what discrete is. It's the whole numbers. What the hell is a random variable? These are the numerical measures of the outcome from a probability distribution. We tend to have a capital X for the category of outcomes. This is silly, because then we do a lowercase x, which is really hard to distinguish unless it's typewritten. These are all possible numerical outcomes. And I'll pause for a bit because I know I said a lot there. Is Destiny 2 a first-person shooter?
It's both. Like there's like first person, but if you're using something like a sword, it's like third person.
Like over the shoulder kind of thing?
Kind of, yeah. There's also like, I don't know, it's different because there's like, you'll be in third person sometimes based on like what build you're using.
Okay.
There's like one hunter and then sentinel.
So this game I'm about to say is probably older than you. EverQuest was a computer game. Like it was a massive. It was an MMORPG. It was like very extremely popular during the dial-up modem days, and like I played for a really really long time in first person, and I was like, this is the way to play. Like in my head, like bitches play in third person mode. Because you're looking at your character's eyes, and so like if someone's attacking you from behind, you don't know until you're going, ow, 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 and you fucking gotta turn around and deal with it. Third person mode, you can see someone sneaking up on you. And I played a really, really long time in first person mode. And then on accident, I switched to third person mode. It was like roll the mouse button and I didn't know it. And I fucking rolled it and I got stuck in third person mode and I didn't know how to change it. And I'm like, oh, this is nicer. I like this better. And all that talk about bitches playing third person mode went right off the window because like this is better. Now I get like a little queasy if I went around in first person mode on games. Like I can spin the camera, even though I'm controlling it, I can spin the camera too much and like make myself nauseous. It's fucking ridiculous. All right, I assume you got caught up, despite all the blither blathering. How does this, let's talk about, remember we did the boys and girls thing? And we said how many girls could we draw? So for like doing this here, X, capital X would be number of girls picked from our problem in the previous two classes. Number of girls picked. Lowercase x was the possible numerical outcomes. 0, 1, 2, 3, 4. So this is like, what are we keeping track of? And this is what kind of answers can we get? And this is the random variable. I'm going to abbreviate that RV. I'll put this up here. Random variable is abbreviated RV because I get tired of writing random variable. I'm going to say it a lot today. And RV is random variable. So random variable is like the big thing, like what's the big picture? A variable is something that changes. You guys ready for more? Anybody need this longer? If so, say something. Okay, no one's in there. Okay, so like let's give another example, not one that we've done already. Let's say Sarah and I play rock, paper, scissors. Hopefully she would be up for the rock, paper, scissors, lizard spot variant, but if she's not, I think everybody knows the rock, paper, scissors game. And we play best of 5. Before we say best of 5, let's just say we play 5 games. Let's start there. So what I would call my random variable here, I don't want Sarah to win, I want to win. So X is gonna equal the number of times I win. Because to hell with Sarah and her luck. Her Jedi mind tricks, reading my mind, figuring out I'm gonna throw paper. How many times can I win out of 5 games? What are my possible outcomes? I could win all 5. What else?
4 and 1,
I could win 4.
3, 2 and 1.
I could also win none. Don't forget 0. If 0 is an option, and it usually is, don't forget it. When we generally write this in terms of probability, this will be, what is the probability that big X equals little x? Or like, what is the probability I win 4 times? We would write probability that X equals 4. What is the probability I win 3 or more times? Because if I win 3 more times, I won. Out of 5 games, I won. Probability that X is greater than or equal to 3. That's what I really want. I want 3 or more wins. I'll put up with 1 or 2. 0 is just getting humiliated. 5 losses in a row and rock, paper, scissors. It's just like they're in your head. They're living there rent free in your head. They know what you're thinking. And I don't want even my wife being able to do that. There's got to be some mystery. You got to be crazy. So this is called a discrete model. Because the outcomes are whole numbers. Well, let me change that. They are countable and limited. There's a limited number of outcomes we can count. They don't have to be whole numbers. If we're dealing with something that has money, you could have 149, 199, 249, 299. Those are like not whole numbers, but if those are our only answers, that's definitely a discrete outcome. So when we do infinite outcomes like continuous data, we'll do that in chapter 7, like I was telling you about. So that was what discrete random variable meant. And now let's talk about what a probability distribution is, because I said this chapter is on discrete probability distributions. So we've addressed the discrete, we've addressed random variables. Let's talk about probability distributions. Before I turn the page, does anyone need it up longer? You good, Sarah? You're over here doing homework or some shit like that.
Oh, I'm making notes.
Probability distributions, that's what I was talking about. Probability distributions. This is a list of all outcomes and their probabilities. And we usually write them in a table. So I'll give you an example, and this is a fucking old example, because this is from when I first started teaching, pre-pandemic. Even when like Netflix was not really young, so I think this was even before that time. Let's do an example where our distribution is on the number of movies streamed on Netflix in a month. Now you'll see from the table that I'm going to give you, this is definitely pre-pandemic, when we had nothing but to do but watch movies and shit like that. I think if you like eliminate all like the TV shows like Stranger Things and shit like that and just did movies, it might be consistent with today. Because a lot of people really don't want to, like, you'll binge watch like 8 hours of a fucking TV show, but you don't want to commit to like a 2.5 hour movie. You know, it's kind of weird. Am I alone in this shit? Like, I will binge watch the shit out of a show with my wife, but she's like, let's throw on a movie. Now you're locking me into something for 2 hours. All right, so, options. So this will be the number of movies. And this is what we call our X. And this will be the probability of watching that many movies. So this will be our P of X. And it's 0 through 5. So this is the probability that X equals 0. You may not have watched any that month. You got 0.06. The probability that X equals 1, this is pretty common. It's the most common answer, or at least was. Probability that X equals 2, 0.22. I'd be curious to see if these still hold up. If Netflix even tracks binge watching versus like a TV show. X equals 3, your probability is 0.10. The probability that X equals 4 is 0.03. And the probability that X equals 5 is 0.01. And I will stop talking for a while and let you catch up.
And to find the outcome, what are you doing to get like the 0.06 or the 0.01?
They counted how many people, and then how many people will watch one movie, how many people watch 0 movies. Let's just assume someone counted this shit, presumably at Netflix, that has the data.
Okay.
Don't go too deep on me here, Mateo. Now, it does lead to an interesting question, because where we're going with this is we're going to find the mean of this data. But like, it'd be a lot easier to find the mean of the data if this is like 3,000 houses and they just had a table of the 3,000 houses and how many movies each house watched, it would be a hell of a lot easier to find the mean. We just add up the number and divide by 3,000, the number of homes. We don't have that done. So let me write that in a second. I did want to point out a couple things. Note that our rules for probability have been met. 0 is less than or equal to any probability listed, which is less than 1. And we can show that the sum of all probabilities equals 1. If we add these up, it should be 1.00. These are our two requirements for a probability distribution. There's a good question. They'll ask you something like this on the homework. They'll give you a list of values and go, is this a probability distribution? First off, look for any negative values, any numbers that are bigger than 1. If there are any probabilities that are negative or greater than 1, no. It can't be that, because that would break the first one. Then, if all the numbers are like between 0 and 1, 0 point something, add them all up and make sure they add up to 1. If they add up to 1, you've got a probability distribution. If it adds up to 0.96, it's not a probability distribution. Something's missing. So it needs to account for every answer. You guys ready for a little more? Is anyone still writing this page? Sarah, you good? So Mateo was asking where we get that data. Let's say we had all the data. This is what I was saying a second ago, but I'm writing it down. We had all the data for all the homes in the survey.
So you write this down or just like,
If you want to, if you don't want to, you don't have to write it down. As long as you understand the concept, we're good to go. Finding the mean is easy. If that's the case, finding the mean is easy. Here, we just have a summary of the outcomes. So when we're looking for the mean of a discrete random variable, like x bar or mu of x, A or 1, use actual data when you can. But option B, if we have summary of data, summarized data, the mean of x is the summation of x times p of x. So we're going to go back to that table we had a second ago. I should have warned Mateo, who writes super fucking small and probably has already written next to his table. You have, haven't you?
no.
Oh, you got lucky. You got so lucky. I'll wait until everybody's done writing this before I go back and we'll calculate the mean here. Lunch.
Yeah.
I had one russet, I had 2 golds, and I had a red. And I said, fuck it. I even brought some for like to have at breakfast time or like between like 9 o'clock, and I looked at it, I'm like, no. So
You just like chunk
it's
out.
already working. Like I ate less food than I ate until I was full. I was not enjoying it after like the first potato. When you're hungry, I ate at like 12, and that's how I was hungry. When you're hungry, fucking, first of anything tastes good. You could probably eat a piece of shit, and it would taste good if you were really hungry. But very, very quickly, you don't want to eat that piece of shit, and that's what the potato was. So like potato 2 was slower, potato 3 was slower, potato 4, I waited a little while, and I said, am I still hungry? Let's wait and find out, because I don't want another bite. All right, let's go back to that table.
Yes.
I didn't think ahead, or I would have left myself some more room. But what we're doing here is x times p of x. We're multiplying this column by this column. 0 times anything is 0. Did I write down the right numbers? Is that it? Yeah, I did. Okay. 1 times anything is the number you start with. 2 times 0.22 is 0.44. 3 times 0.10 is 0.30. 4 times 0.03 is 0.12. And 0.01 is like a penny. If we've got 5 pennies, we've got a nickel. If we add those up, I got 7, 15, I got a 9, carry the 1, 10, 13, 14. I got 1.49. Is that the direction? Okay, because that was up. That's okay, I think I knew what you wanted. I wanted to make sure you didn't want something that was written above the other direction. So mu of x equals 1.49. And that's what I mean by sum of x times p of x. I tried to start that potato shit yesterday. I had it for lunch. And like dinner time, I'm like, no, I can't do it. It's fucking sitting here at home. We had some like frozen burritos. And I'm like, okay. She hadn't planned on cooking dinner because she knows just eating fucking potatoes. But now that I'll be here a lot all day. It's too early for that shit.
Couldn't be eating potatoes.
What?
I said I couldn't be imagining eating potatoes, just potatoes.
And really, really quickly, if you stop eating because you like it. And so, like, if you eat 2 weeks of just like the bare minimum to survive, you reset your eating habits. It's long enough to reset your eating habits. Like after this, if I make it the full 2 weeks, like what I eat afterwards, well, like a lot, portion control is a lot easier. Otherwise, it's easy to like, how big's my plate? That's how much room I have. You know what I mean? I bet you fucking young active boys get to eat a lot.
I mean, I can't, but
High metabolism. You guys ready? Okay.
Can I just see what the drill?
If you're, take your time. I don't want to rush you. We got time. Because you gotta be near the end. some of you have started chapter 5's homework. I know Sarah has, as of last night she had. I don't know if anyone else has. Hopefully you guys did chapter 3, because it's now in that late category. And you know what? I wanted to say, when I looked at it this afternoon, I wasn't able to click on one of those assignments. And it's supposed to allow you to work late, so I need to go in and check it. Note to self.
I think it lets you. It just says that is late work, and if you want to like review it or like work on it, it's not gonna be like full credit.
Okay. Note to self, check. Late work. Love you too. You too. My note to self is sending the message to my wife, because I won't look at a fucking notepad list on my phone. But if I text her, I'll get home and she'll be like, you texted me some shit. I don't know what you meant by it. Because I usually just say just enough for me to go, oh yeah. She would be like, what? Okay, so when we have the actual data, what we end up getting is X bar. This is X bar right here. Summarized data, I'm sticking with the mu of X. This is our theoretical value. And X bar is based on actual data. Now, if we had the actual data, we would have X bar. But we saw with the law of large numbers we've talked about recently, as the number of households increases, that's for this problem in particular, it's really as n increases, because it may not be houses. As the number of households increases, X bar actually approaches mu of X. So that like X bar minus mu of X is approximately 0. They're like, if you subtract one from the other, you're gonna be really close to 0. It's actually going faster than I thought.
Maybe that's why they're in chapter 6.
There's 3. I had intended on doing 6.1 and 6.2 today, but that was going off the number of pages. But some of these are just sentences that take up a lot of page space on the page, but not really a lot of having to fucking explain it. So I was basing my time frame off 10 page length. If it's only been like hour and a half, 2 hours when I'm done, we'll knock out 6.3. It's only one more section. It's a one pager. Did you guys have a good weekend? Yeah. I woke up at like fucking 3:45 in the morning and I tried to go back to sleep. And I lay there for 2 hours. And I don't know that I got back to sleep. I rested, but there was no sleeping. That's that's fucked when you go to bed at like 2:30. It's not enough.
I'm house sitting in Springville for a ranch, so I had to feed the cows and the chickens at 5:30 this morning. And then I couldn't fall back asleep, so I was just like, I have nothing to do.
That's not my idea of house sitting.
I feed
Did anybody else, when she said I was house sitting, think that involved fucking feeding cows?
She said on a ranch, so.
Yeah, but at the start, I was house sitting this weekend. Then she added on a ranch. Still, even with the added on the ranch part, my first thought wasn't up when the cows fucking get up. It'd be like, nope, you motherfuckers are eating when I get up. I'm not a fucking farmer.
So the thing is I house it for a lot of different kind of people that just want their plants watered, and then I have a lot of people that have ranches that like me to house it, because it's hard for them to find someone that can like take care of their livestock
But
while they're gone. So I've been doing a lot of that lately, and yeah, you get it. But
do you stay at their houses or
they have
you?
milk, I stay at their house. They have a milk cow, but she's not producing right now, so I don't get to milk.
I don't get to milk. It's not like I don't have to milk. I like fucking just tugging that motherfucking cow off.
I grew up doing that kind of stuff, and now I live in town, so if I get to go do it for a week or two, I don't mind.
And they pay you?
Yeah, and I get to eat all the food in their house.
That's a fucking good, that's a good gig, you got a good gig.
Oh, yay. I usually take my dog too, so.
Well, especially if it's a fucking ranch.
Yeah.
Huh,
It's great.
pause.
Yeah.
All right, so back to business. That's why I paused. That was gonna be way too long of an interruption. So, since the mean value of a random variable, remember that's mu of x here, that's how we label it. Our variable, the x tells us what the variable is called. Mu, and we always say mu of x, I don't know why. It's always x, there's never a fucking mu of y. It's always mu of x. No, that's not true. It's usually mu of x. So mean value of random variable mu of x represents what we expect to happen in the long run. Like, when I say long run, I mean as n goes large. It's what we expect, so we call it the expected value. Expected value means mean value. But when we're doing something with a discrete random variable, they'll say expected value is e of x. And this is your sum of x times p of x. And that was one of the first things I wrote on the first page. You say you just want to learn some stats, but you learned some life lessons there today, bud. Whatever you do, don't let them gild you. Don't let them trick you with a nice short word. It's not pretty.
It's also not.
Let's do, have you guys seen roulette?
No.
Let me show you guys a roulette. If for those of you that haven't seen a roulette table, let's put a roulette table up here. I'm not drawing a picture. That's fucking batshit crazy, but I can show one. I typed the word roulette for my password. It doesn't like it. Imagine that. Mother, you just fucking randomly logged me out? I gotta re-enter my, okay, caps lock. I got all flustered and entered it wrong. Second time. The first time it was right. Roulette. Maybe we should go with the roulette layout. click on images. Let's find a good one. So there's two here, I'll show both. Oh, that's not showing it all. F all that. I think that, well, the one I want to show you part of that is, see how there's a green 0 or 1 0 and 2 zeros? Some boards have this layout, other boards have this layout with a single 0. Now, this board with a single 0 is the one that is, players never have the advantage in the casino, as we'll see. But the advantage of the house is minimized when there's just 1 0 rather than 2. The standard board has 2 zeros, but everything else on the board is the same. They have these numbers 1 from 36. Half of them are black, half of them are red. You can bet on red or black. You can bet on the number being odd or even. You can bet it being in the first 18 numbers or the last 18 numbers. You can bet on it being on the first 12, the second 12, the third 12. Or you can bet on these rows of 12 numbers, which are not the first 12, but that are just numbers. You can put your money on a single number. Like you could bet all on 13. You're like, I love the number 13. Put all my money on 13. You could put it on one of the lines between them and bet on 2 numbers. Or you can put it on a corner and bet on 4 numbers. Or you can bet on 0 or 00. That's the layout of the board. So let's look over how the probabilities work, because this is really fascinating. We'll just do if you bet on a single number or not. So in roulette, the standard table has 0, 00, and the numbers 1 through 36. You will hear them say ought for 0, and that's double ought. That's some casino slang for you, for the zeros. But as we can see, if we have the numbers 1 through 36 and we add 2 more numbers, and these 2 are green, and the rest are red and black. If we add those up, there are a total of 38 choices, 38 numbers. And a single bet on number.
Is that 0, 0, 0?
0 and then 0, 0. 2 different choices.
Wait, how's that
Here.
different?
So like on the picture, one box was a 0.
Oh.
And another box was 0, 0. Those are things. Okay, so they have this wheel, and the wheel is perpetually spinning. It's on a perpetual motor at a certain speed. What they do is they flick a marble the opposite direction that the wheel is spinning. Eventually, friction wears that ball down, and it starts sliding down into the bottom. And in the bottom, there's all the numbers available for this, whatever's on the table, and a little bucket for each of them. Sometimes it lands right in the bucket and stops. Sometimes it hits the bucket, bounces out, and goes to another bucket. It can be exciting watching roulette, depending, like, oh, my number got hit, oh, I guessed flat. Or, oh, I didn't get my number, oh, look, it got the money. So there's a lot of different shit. A single bet on a number pays 35 to 1. I'll put $35 to $1, make sure it's clear. When you see something like that, this is worth saying. If you see something like odds like this, 35 to 1 is called odds. What this means is, in general, when we're not talking about money, it means 35 outcomes one way, one outcome another way, which means 36 outcomes total. So, this would be great. In all reality, this is kind of like 1 over 36, and this is like 35 over 36. If we did a probability thing. That's not what happens in roulette though. Because 0 and double 0 make it so that the denominator is not 36. But that's what 35, when you see odds, and if you're ever seeing like, how do I make odds into like proportions? This is what you do. You add up the proportion, or add up the two things that make up the odds, and you can write them as proportions like this. So like if you see 3 to 2, sometimes they'll do it like this. Another way of writing odds is like that. Another example of odds. There's 5 outcomes total. So one is going to be 3/5 and the other is 2/5 for probability when you see odds. The odds of winning are not the same as the payout odds at a casino. The odds of winning are 1 in 38. The odds paid out are 1 in 36. So let's see how this turns into, I'm going too fast, slow your shit down. Let Jean-Luc get his groove on. You're already done cheated him out of fucking 20 minutes of lecture today. Got a text from his parents. Quit wasting my son's time. So let's look at this. We said we want to write it as a table. Let's look at that. Let's do the RV, the random variable, in terms of a player's view. Player view, random variable on a roulette spin. And we're just going to do a single number bet. So let's say I like the number 13. I bet on 13. So maybe I'll put what the outcome means here, and then we'll do our x and p of x here. Fucked that table up good, didn't I? Big old fucking line through it. This is what we call a scrub. Amateur up here. So the two outcomes I can have that I care about on this single thing is the ball hits 13 or ball misses 13, right? I don't care which number it hits. If it doesn't hit 13, I don't win, and I don't care about any of the other ones. My random variable, I should make my random variable how much I win. Because that's what I care about, right? I care about what I win. So the 35 to 1 gives me some information. If I hit, I get the 13, they're going to pay me $35 for every single dollar I bet. If I bet $10, I'm getting $350. If I bet $1,000 or $100, they're giving me $3,500. That's a good ducats rate. If I misses, I'm just losing $1 for every, well, in that scenario, it's $1 versus $35. If I went up to $100, I'd be clearly losing $100, but let's just go with the base bet of $1. The probability of me hitting, there are 38 outcomes, and only one of them is a 13th. The ball misses, there are 37 outcomes out of 38. And we want to see this as a decimal. We got 0.0263 for that one. And we've got 0.9737 for that one. Let's make another column for our expected value, which is the sum of x times p of x. Did I not pull out my calculator? I did not. $35 times 0.0263, 0.9205. We are talking about money though. So in terms of money, I should only do 2 decimal places. And it's positive because the 35 was positive. All the numbers are positive here. So this is dollars and this is dollars also. I can see right away -1 times this is just going to be negative, put the negative first, 0.97 to 2 decimal places. So if I add these two up, I'm going to get negative 0.05. The expected value in roulette on a double-aught table, double-zero table, is lose a nickel for every dollar bet. Wagered. Interestingly enough, every bet on the roulette table is a nickel. Same expected value. If you bet on red or black, or if you bet on odd or even, they pay you 1-to-1. You either win $1 for every dollar you bet, or you lose $1 for every dollar you bet. When you calculate out the expected value, this is what you get, a nickel. Doesn't seem like a lot. Is there any way I could lose a nickel at a roulette table with one spin? No casino's gonna let me bet a nickel. Right? This isn't even one of the outcomes. I bet $1 and I'm either gonna get paid $35 or I'm gonna lose $1. So the expected value is the average in the long run. In the short run, I might lose a bunch of dollars, I might get lucky and win $35. But in the long run, if I spin a lot of times, I'm gonna lose a nickel for every spin. Guess what? Casinos don't do a few spins. Let's say there's 100,000 spins in a month. Even if it's only of $1 each. There's only one person on the table and they're only betting $1. Or I do 100,000 spins in a month, and I just wanna like be there as long as I can, so I bet a single dollar every time. That's a more realistic way of saying it. My expected value is, for the overhaul, I did 100,000 spins and I'm averaging a negative 0.05 each spin. 100,000 times negative 0.05 just so you see it. I would lose $5,000 in a month in the long run. There is no way that's going to change. It might be 4,995, it might be 4,900, it might be 5,150, but it's somewhere around $5,000. It doesn't matter if I fucking win 10 times in a row. It lands on 10 spins in a row. If I keep playing 100,000 times, all those other numbers of not hitting 13 are gonna catch up. And when you have that many spins, the long run, the law of large numbers plays out, and I will lose that much. If I only did 10,000 spins a month, it'd be 500. If I only did 100 spins a month, it would be $5. This is where the casinos make money, because most of the roulette tables, $1 is not a valid bet. Like some of them, if you go to like a good, like a casino that has like, we're gonna let poor people in, for that, a casino, $1 bet on a table game is the poor person's game. But a lot of times people don't just bet $1, they're like, I'm gonna bet on this and this and this and this and this, and they go all over the fucking place. So like, they're making bank. This is just me betting $1 100,000 times. There are people that play $100,000 in a day, easily, betting $100 a time. Like millionaires where they don't give a shit how much they lose. Millionaires care about 100,000. Billionaires don't care about 100,000. Isn't that kind of interesting? Roulette is one of the few games where like the expected payout is the same. It's a little bit better for you when there's only 1 0. Guys ready for more? Another problem we'll see is something where like, let's look at like a term life insurance policy. We'll go take a break after this one. if you need to go to the bathroom. I know we took a break earlier, but it wasn't a bathroom break. Oop, wrote wrong thing. Lady pays $530 for a term life policy annually. She annually pays $530 for life insurance. And that policy, the policy is worth, let's say it's worth $250,000. Don't count on your parents to have a life policy like that. I don't think my mom's life insurance policy was, might have been 15,000 total, me and my brother got half. But I wanna say that's too high. I don't think I got that much. I'd have to look, she passed away last year and I was doing all the finances. Most people can, because the more you have that life insurance policy worth, the more it costs you annually. And people like, a lot of people don't make enough money to fork out a lot for life insurance. So the probability of survival for a woman of that age in her conditions is, there's a good chance of survival, 0.99791. And we're going to compute the expected value for the company. So we'll do what we did before. We'll make a table, we'll describe what the outcome is. We'll write down what X is. We'll write down what P of X is. And we will calculate X times P of X so we can add it up. How was that? Like a fucking, someone stepped on a shot.
I was silent, I was like,
So what are the two outcomes of the life insurance policy? She lives, she dies, right? So if she lives, what happens? From the life insurance company, let's make the expected value, we're talking about money here. Monetarily, what happens for the life insurance company?
She had to pay $530.
She had to pay $530, which means they earned $530. This is the dollar category. I'm not going to write the dollars down here, but we'll just write plus 530. She dies. That's what I wrote. That's fucking great. She dies.
It wouldn't be a negative 530 because like she's losing money because she's giving.
We're doing it from the company's perspective, not her perspective. If she dies, she ain't gonna see a goddamn thing. She don't care. It's for her children. So the company is really the one that's like, why would you offer this life insurance? You can look at it from in terms of the person, but like in reality, no one ever would because you're dying either way. If she lives, we know the probability of survival is 0.99791. They gave that to us. Financially, what happens if she dies. They gotta pay out the $250,000, right? That's a negative. But they've collected $530 already. She pays it up front. They've collected $530. So their net loss, they're actually losing $249,470. That's their net loss. What's the probability that she dies?
100%.
In a given year?
Oh,
Of course she's gonna fucking die.
50%.
What?
50%.
God, I hope not.
It's gonna be 1 minus all those numbers.
So the probability of living is this. Remember, probabilities need to add up to 1.0.
Oh.
So we're gonna take advantage of this and we're gonna do 1 minus 0.999791 to figure out what that is.
0.002.
0.00209? So if I multiply this, I get negative $521. Oh wait, I got them in the wrong order. Positive one is plus $528.89. That's a positive. And the negative one is $521.39. If you multiply x times p of x. If you add this up, this is $7.50. That's our expected value, or the company's expected value. They only make $7 out of that $530. Their average earnings for a year is $7.50. But insurance companies insure shitloads of people. If they have 1 million customers, they have 1 million times that $7.50, which is $7.5 million. So the idea of making $7.50 per policy doesn't sound like a lot, but if you think about how many policies they do, they're bringing in the ducats. Even though they have to pay out $250,000 sometimes. In the long run, now, there are some years that will skew this. Like I bet there were some businesses that were very unhappy during the pandemic. That probability of survival went way down. We're about to go on break, but I want to show you how to do this in StatCrunch. In StatCrunch, we're going to do stats, calculators, custom. You need a column for your X's. And StatCrunch will call this values. And then a column for your P of X. And they will say weights here when you ask for this. These are your values. This is also the different outcomes. numerical outcomes. So while you guys are writing that down, I will get StatCrunch loaded up real quick. Blowing you kisses. Are you still writing, Gianluca? If you are, I can wait, otherwise I'm,
That's fine, I just finished it.
okay. So what I'm gonna do, I like to label the rows real quick, so I'm gonna go up here and click on these and call this X and P of X. That way, when I'm looking later on, I know what to find. And we had 530 in this one, and we had negative 249, 470 in this one. And the probability was 0.99791 and 0.00209. So this is the table we just manually wrote. So I'm going to say stats, calculators, custom. It's at the bottom. Everything else on the calculator list is alphabetical except custom because someone's a dumb shit. Right? There's no reason to put it out of order. I can tell you right now, you're not using Couchy very often. You're not doing this gamma shit very often. There's no reason to have it out of order. So we'll click on custom. And I told you it would ask you for values and weights. So if you label them X and P of X, values are your X and your weights are P of X. If you didn't label them, you got to find out what columns they are and just tell. And we click compute. And it tells me my mean value is 7.5. Since we were talking about money, that's $7.50. That's it for that section. Let's take a 10-minute break so you guys get more water, go to the bathroom, something like that. I will stop this video and we'll do a second one for the second video.
And then we're doing 6.2 next.
We're doing 6.2